I will present today a work we are doing now in a European project named ecodriving, which purpose is to develop a driving assistance system to promote eco-driving, and in two different kinds of systems. One is embedded and one is a nomadic device. So I will try to focus on HMI and nomadic device aspects today, despite the project is not only on that subject. I will start to introduce eco-driving, what is exactly eco-driving and why inducing eco-driving is not so easy in a real condition. So eco-driving is a highly complex task because you need to do many things at the same time. You need to control the vehicle, you need to adjust your speed, your trajectory according to the driving environment. You have to deal with hazards, so you have to be aware. And you also have to make strategic decisions for the navigation process. Usually, eco-driving is presented to people using very short and summarized and very simple advices that we may call tips. You can have, usually it's reduced to the 5 golden rules of eco-driving. So even if the driving is complex, people try to summarize it in very simple advices, but that leads sometimes to a misunderstanding of what exactly is eco-driving. So for example, just to give you clues about what I just said, you have a graphic on the right, which is 6,000 trips recorded during NISA French experiment in the past, and you have the average speed on the x-axis and the fuel consumption on the y-axis. And so you see that the faster you go, the less the less your fuel consumption is. Of course, this is an aggregated result, but it's just to show you that eco-driving is not so obvious. It's not only related to speed. For example, we studied some previous ISA studies, and we thought in the past that just following the speed limits will induce fuel consumption reduction, and it's not the case. It's not the case. Using an ISA, you have almost constant fuel consumption. So maybe reducing speed is not the only, nor is the optimal strategy for eco-driving. So we cannot obtain eco-driving just by giving advices on speed, because there are several factors that can influence the fuel consumption and the emission. Another example is about the fact that people may misunderstand eco-driving and try to save fuel always, each time they can. So sometimes you have this specific behavior which is called hypermiling, which differ in terms of tactics. The hypermiler driver trade-off safety for fuel economy. It means if you never stop to the red lights, then you save fuel. Okay, but this is not a safe way to drive. So eco-driving does not mean driving slowly, but means driving better. So of course, what is the definition of better? Here is the definition we propose with some of my colleagues. Eco-driving could be seen as a multi-criteria optimization during your driving task, in which you have to optimize energy consumption, but also safety, travel time, and comfort. So it's quite a complex process for the human mind to optimize this at every time. Here you can see that if you try to formalize this idea, you have here the hypermiler, which trade-offs safety for economy. Economy is the main aspect. So using these 4 comfort, eco, safety, and time, you can derive 4 kinds of drivers. And of course, you are not always an eco driver, you are not always a sport driver. You could change during your trip from different states. So this is another issue. So we want to promote driving efficiency in an energy way. I mean, efficiency in the sense of reducing energy consumption. So one observation is that the actual systems are not sufficient because most of them are devoted to safety first. And everybody knows about one system that with a poor HMI, which is in all the cars now, it's the fuel gauge. That show you the instant fuel consumption of or the average fuel consumption. If this system will be sufficient to induce eco-driving, then all of us will be already eco-drivers. Obviously, it's not the case, at least for me. So I wanted to show you that the fuel gauge is not a good tool to induce this kind of driving. For example, you have very fast variations of instant fuel consumption. That's very hard to follow and very hard to understand. More related to infrastructure than to your driving style. There is a tendency of the drivers to stop accelerating when fuel rate increases, of course, but often this means that you don't reach the optimal RPM for the engine. So if you look at the average values, then after 1 year or 2 years of using your car, the average value doesn't change, so you don't see any effect, so you don't see any information. So this is not a good tool to learn. And the goal in the ecodriver project is to build a system that helps the driver learning and maintain an efficient driving style on the long term. So just to introduce the ecodriver project, the name means that this project, the goal is to support the driver in conserving energy and reducing emissions. We have a target which is very ambitious and, to my opinion, will not be reached, to reduce by 20% the fuel consumption of road transport by promoting the adoption of a green driving behavior through a specific dedicated HMI. Driver will receive eco-driving recommendations through an HMI which can combine visual, acoustic, and haptic messages at the same time. So a new kind of HMI, and incorporating message and information that adapt to the driver himself and to the driving situation is just driving now. And also, we don't want any compromise between fuel consumption reduction and safety. And you could think that eco-driving, because of the hypermiler driver that could appear in each driver, you can have this kind of compromise, and this is very difficult to deal with. Sometimes it's opposite; it's in the opposite direction. Eco-driving wants you to do something, and safety would like you to do another thing, and you have to to choose. And of course, you have to choose safety first. But driver could forget that. Just to give you an idea of the partners in the project, you may know most of them. Here is the way we summarize the goals of the project. So we want to achieve a 20% reduction. We want also to test and compare effectiveness of built-in navigation systems, built-in driving assistance systems, and nomadic devices system. And in order to see if there is differences in the effect on driving behavior. We want to maximize system effectiveness and acceptance by adapting the eco-driving, the interface to driving style, traffic conditions, and vehicle type. And we also want to enhance driving safety. And also the scaling up or work package that are present in most of the projects. Another idea to maximize the effect of the system is to try to provide the right feedback at the right moment. And this has to be done thinking that we need to give very complex information to the driver in a very simple way. So it's never an easy task. So we are still thinking in the project about what information do we need to provide to the driver, when do we need to provide it, and how. We plan to have 3 different kinds of information. A preview by the means of an electronic horizon. You can advertise the driver about a hill, about a traffic jam, and give him some driving advices suitable for that. For example, slow down if you are entering a hill, or stop accelerating at the top of the hill, before the top, because you have enough acceleration to go through the hill and go down. We also need to provide instant information about a kind of eco index, for example, and aggregated information about the level of eco driving. And in order to improve the learning effect, we want to provide post-drive feedback and let the driver follow his history in the previous trips, and in order to learn and to see the progress in his driving activity. We will have different implementation of the systems, and this is a major issue for us because we have a kind of embedded system, built-in system, which is something connected to the internal computer in the vehicle, and so make use of many sensors that are in the vehicles. So we have a lot of very precise information, so we can build precise algorithms. We can integrate a map that data inside, so we have the electronic horizon, so we have a lot of information, and we can use that to give precise information. But we also want to have light versions of this system in order not to build a too complex or too expensive system. And so we have TomTom in the project that will provide an eco-driving function in their own system. So it's a GPS-like device. You have the usual smartphone, which I call the standalone smartphone, which means that you have to do everything I told you before, just using the phone sensors. But it's possible now, you have the possibility to add an OBD2 connection to the smartphones. This OBD2, maybe some people know that, for less than 50 euros, you can buy something that you can plug on the CAN bus of the vehicle, and you can get the information from the vehicle and transfer that information to the smartphone using Bluetooth or Wi-Fi. And with that information, we reach the same level of possibility that we get here. So for me now, smartphones can be used as a built-in system if you have this information. This information means you have, for example, the engine RPM, the brakes usage, the light sensor, and also the fuel consumption. If you don't have this OBD2 connection, then you have to estimate the fuel consumption using only GPS data and speed data, and so this is not an easy task. Also, ecodriver project just started 1 year ago, so that's why I talked to some of the work we have to do in the future. And we have a great challenge. We have to build the algorithms, we have to build the HMI and the system in parallel. We are now just in the middle of this process, and we want to use a common HMI for all the different system implementations. So we have to use ideally the same HMI for the built-in system and for the nomadic. Depends on the screen size, so you have to adapt it, and not easy also. And we will take decisions on HMI in the next year after some experiments that will be carried on in January and February next year in various sites in order to know what graphically which kind of HMI works well, if it's a bar, horizontal, vertical, symbols, colors we may to use. So it's not yet decided. Of course, we have clues about the state of the art. This is an example just to show you what the kind of approach is envisioned by the OEM partners for the built-in system. So here it's the example of BMW that is working on a new dashboard with some, if you have here some bubbles representing the CO2 emissions, and the fuel goes here. And using an head-up display with different colors, and for them, eco-driving will be blue, and non-efficient driving will be red. This is usual, but blue is not usual. Anyway, this is another example coming from an old project, French national project, which is called Jericho. So this is the kind of HMI you can think about inside the car. This is not the purpose of today, and that's why I will switch to nomadic devices. I just recall that we have three different kind of nomadic devices, so maybe the term nomadic devices is not precise enough, because it's very different in terms of HMI if you are thinking about a GPS-like device and a smartphone device. Because this one is kind of dedicated device to drive. The smartphone is not dedicated to drive. So people may want to call somebody. So you need to let them use the phone for the usual purpose. Okay, so the most difficult part is to do something with just a phone and no information on the engine, RPM, and so on. So what about the state of the art that applications that already exist on smartphone? We saw a lot of them, but most of them are not documented. It means that nobody knows the algorithm inside, of course, but for the free application we could have some clues about that, but it's impossible to find any information. You have very different HMI. I just give you two of them. Very different in types of HMI. So we still don't know which is the most efficient. Which will be part of the work in the project. If you have some clues, I'm interested. They are mostly based on visual displays. That means there is few auditory feedback until now. For eco-driving, of course, there is GPS-like application, but just for eco-driving point of view. And our concern is, for example, that from a user point of view, you have different usage for such an application. You can have, to my opinion, the main usage is the navigation usage. But you can use such an application to improve your energy efficiency, the speed camera detection, the traffic information. You have many different kind of usage that may be useful for the driver. And very few applications are providing these services at the same time, because it's difficult to put everything on a small screen. But if you have the choice between an eco-driver application and a navigation application, which one will you use? And this is one of our concerns. If we build only an eco-driving application, then do the people will use it or not? And it's not clear. I think we need a navigation service. But okay, let me continue on this HMI. It's known that you can reach a good level of eco-driving just by asking the driver to follow the tips, the clues, the driving description of eco-driving. But if you do that, the long-term effect is unsuccessful. It means after 2-3 months, you lose almost all what you have gained. So more than let the people be focused on eco-driving, we want them to maintain a good level of eco-driving. There exists some fuel efficiency related HMI that have been studied already. It is known, for example, that considering fuel instant information is perceived generally better than aggregated information. I mean, if you are driving now, and if the application gives to you an information about you have done 5 minutes ago, then it's not relevant for you. So you are more focused on instant information. But if you do that, there is very little evidence of long-term positive effects. If you give only instant information, then you may lose the global view on what you have done the last few months and how you improve your driving. We also have results on haptic pedals, but it seems that they are not accepted by the drivers, despite they are quite efficient. Auditory feedback, it's perceived often quite annoying when you are driving. I recall that I'm not an expert, so this is what I read from the literature. So if you have some other ideas, let me know. But we want to have the auditory feedback, but let the driver close it. We don't know. It's not decided. So we just start the process of building the smartphone application. We have a beta version, but not the final one. And this is the kind of work we have done just last week in a project meeting, because you have to start with a kind of flow chart and describe the screens and how they interact and the way they interact. And for example, you can have this kind of links. You change the screen when the vehicle starts moving, or you can change the screen or the level of information when the vehicle is stopped. So this is something that it's interesting to use, to make use of that capability of nomadic devices. This is a draft. This is quite complex to do. Everybody has different ideas, but this is now the level of detail we reached last week. Considering HMI aspects for building smartphone applications, we think that there already exist lots of applications, and we are dealing with Android smartphones, so we think we should start by reading and adapt to the Android standards, because there is some guidelines given by Google in order to harmonize everything. If you want to improve the way people understood the application, then we need to follow the same guidelines. So we need to use action bar instead of menu buttons, and usually every people want to add a menu. But and we also have to keep it intuitive and very easy to understand, because people won't read a manual before using it. Another important consideration from us in ecodriver is to adapt to the driver's motivation, because especially when we are talking about eco-driving, motivation of the drivers differs. For example, some of them have the time, so they are just focused on saving money. Some of them don't have time, and they don't care about saving money, but they could care about environmental factors. So if you want to improve the efficiency of the application and the efficiency of the system you provide, then you need to adapt to what they want to do. And there is also nag influence of other factors on eco-driving behavior. You have the traffic, you have the weather, the road type, the power of the vehicle, and we need to adapt to that, and it's quite difficult without asking the driver which type of vehicle do you have, and maybe we could ask the driver to log a baseline for himself and evaluate the eco-driving level according to that baseline. So it's quite complex, so it's not decided yet, but for sure we need to try an adaptation. So this is my last slide, because I don't have any results considering HMI for you today. but I have a lot of questions for you. And for example, what I told is it interesting to have a nomadic application only for eco-driving? From a research point of view, this could be okay. And this will be the case in the built-in system for research, but for TomTom, for example, for sure they don't want something that is only eco-driving because they want to use the navigation services. And so this is a question. Is it possible to have the two kinds of information on the same screen? Navigation information together with eco-driving information. So do we need to add the navigation service? But possible to do that. We could use Google, but Google is free, but not if you want to use Google for some activity. You cannot interrogate the map more than 3,000 times per day. So it's there is some limitation and you have to pay if you want to do more. How to adapt to driver's motivation? We need to detect the driver type. We need to know him better than Google know him. And that's not so easy without asking him any question. And if you ask the driver a lot of questions, then you could stop using the application. So another question we have is the following. Is it acceptable to let drivers interact while driving? Because depending on the skills of the driver may want to, while he's driving, to focus on a certain aspect of the eco-driving. For example, the acceleration. I want to be focused today on, I want to improve my acceleration behavior. So give me detailed information on acceleration. So you could enter a learning mode with a lot more of alerts concerning acceleration. So, so we need the driver to interact with the screen. Is it acceptable from a safety point of view? I'm not sure, but I'm not the only one to decide. So, is it also acceptable to use a speedometer? Speedometer information is known to be quite efficient. People understood this. But if you do that, you have two speedometers. Which one will you use? This may increase the mental workload of the driver. It's not decided, but this is known, I believe it's the EcoMove project also. It's known to be efficient. How many different information can be provided? Because eco-driving is related to acceleration, deceleration, speed, gear shifting. So you have at least 5 different kinds of information to provide. How to put everything on a small screen. So we have to make choices. And also the last thing is very interesting. It's also known that you can improve the attractiveness of such an application by interacting with social networks. So induce competition between drivers, not when you are driving, but social competition. Look at me, to go to work, I get this score, 99 over 100, and you only reach 96, I'm the best. But this is also known in the literature to be efficient. And the last point is the ability to connect to a website. If you want to look at your previous history, if you want to look at curves, for example, from your home to your work, it's a kind of a trip you do every day. So you can use these specific trips to see the progress you made. And all this information cannot be stored on the phone. So it needs to be transmitted somewhere on a website that people could use to learn. So this is the approach adopted by Fiat. They have a kind of USB key inside, and they provide a website and the software you could use at home to improve you. But it's available only for Fiat buyers, and I've not tried it. So this is still the questions we still need to answer, and we will obtain answer in a few months. But if you have some clues for me, then I will be happy to hear you. Thank you. And if you want more information, Oliver Karsten is the the boss of the project.